Mysterious fossil rewrites the story of skin and feather evolution in reptiles. Imagine a world where the story of how reptiles developed feathers and skin isn't what we thought it was. Now, thanks to an unassuming yet extraordinary fossil named Mirasaura grauvogeli, a creature that translates whimsically to Grauvogel's wonder reptile, this possibility is becoming a reality. This remarkable discovery is challenging long-held assumptions about the evolution of skin and its appendages, such as feathers and hair, in some of Earth's most ancient creatures. These groundbreaking fossils, unearthed from the Grès Voltzia site in northeast France, a location dating back to the Middle Triassic period, approximately 247 million years ago, reveal some of the most astonishing soft tissue features ever documented in prehistoric reptiles. As two of the authors behind a recent paper on these findings, published in the prestigious journal Nature, we are thrilled to share how this discovery is reshaping our understanding of reptilian evolution. One of the most striking aspects of Mirasaura is the prominent crest running along its back. This feature is unlike anything previously seen in reptiles. It consists of elongated structures that are neither scales, feathers, nor hair. Until now, scientists believed that complex skin outgrowths like feathers only emerged much later in evolutionary history, specifically in birds, dinosaurs, and pterosaurs. It was widely assumed that these structures arose from a single evolutionary origin shared by these groups. Meanwhile, all other reptiles were thought to possess only simple scales. But here's where it gets controversial. Mirasaura has completely overturned this paradigm. The size of its dorsal crest is immense relative to its body, with long, blade-like extensions forming an elaborate structure. Upon closer inspection, the crest appears to be composed of overlapping appendages, each featuring a narrow central ridge and a lobed outline. These traits bear a resemblance to the shaft and overall form of modern feathers. Yet, there's a twist. These structures lack the intricate branching patterns characteristic of most bird feathers today. Moreover, Mirasaura isn't closely related to birds, dinosaurs, or pterosaurs. Instead, it belongs to a far older group of reptiles known as Drepanosauromorphs, which lived exclusively during the Triassic period. What makes this discovery even more fascinating is how well preserved the soft tissues of Mirasaura are. They appear as a thin brown film rich in fossil melanosomes, tiny cell structures that once contained melanin, the pigment responsible for coloration in living organisms. Our research team at University College Cork, alongside collaborators worldwide, has made significant strides in studying fossilized melanosomes across ancient vertebrates. These microscopic pigment granules not only allow us to reconstruct melanin-based color patterns in extinct animals, but also provide insights into their soft tissue anatomy. Through meticulous examination of Mirasaura's fossilized tissues and advanced statistical analysis of its preserved melanosomes, we've uncovered compelling evidence suggesting that its skin appendages share developmental similarities with feathers. However, whether these structures should be classified as true feathers remains debatable. Unlike typical bird feathers, which exhibit a highly branched structure, the soft tissue blades flanking the central shaft of Mirasaura's appendages show no signs of branching. And this is the part most people miss. Some modern birds, like turkeys, have unbranched feather-like bristles, such as those found in the turkey's iconic beard, while certain dinosaurs and pterosaurs sported similarly simple filaments. Even flattened, strip-like feathers lacking branches, but possessing a central shaft, have been identified in some dinosaur fossils. Experts consider these unusual structures to represent an extinct type of feather. Could the resemblance between these enigmatic fossils and Mirasaura's skin outgrowths hint at deeper evolutionary connections? Or is it merely coincidental? To complicate matters further, recent studies on developing chick embryos demonstrate that manipulating specific genes can cause feathers to lose their branched structure entirely. We're currently diving deeper into the morphology and composition of Mirasaura's unique structures to better interpret their anatomical significance. Regardless of how they're ultimately categorized, our analyses consistently place Mirasaura and other Drepanosauromorph reptiles at the very base of the reptile evolutionary tree. This finding aligns with data from developmental biology, indicating that the genetic toolkit necessary for producing complex skin appendages likely originated over 300 million years ago during the Carboniferous period. In essence, Mirasaura provides the first direct evidence that such complex features appeared early in reptilian evolution, long before the rise of dinosaurs, birds and pterosaurs. This revelation wouldn't have been possible without decades of painstaking conservation efforts. The earliest fragments of Mirasaura were discovered in the 1930s by Louis Grauvogel, a dedicated fossil collector. After spending decades in the Grauvogel family's possession, the specimens were donated to the State Museum of Natural History Stuttgart in 2019. Their careful preparation unveiled their profound scientific importance. Now, Mirasaura forces us to rethink what we know about reptilian evolution. Even before the age of dinosaurs, these ancient creatures were developing anatomical traits previously associated with much younger fossils. This opens up exciting new avenues for future research, encouraging paleontologists to explore fossils from diverse reptile groups and earlier time periods. So, what do you think? Should Mirasaura's appendages be considered a precursor to feathers, or are they something entirely different? Let us know your thoughts in the comments below. We'd love to hear your take on this game-changing discovery. Unveiling a new prehistoric reptile, a feather-like marvel in the fossil record. Imagine a creature that defies every rule you thought you knew about ancient life. What if I told you there's a reptile that looked like a cross between a chameleon, a monkey, and a bird, all while sporting a feather-like crown that no one could explain until now? This is the story of Mirasaura grauvogeli, a 6-inch-long marvel that's rewriting the playbook of evolutionary biology. But here's where it gets controversial. This discovery challenges the long-held belief that feathers and fur are exclusive to birds and mammals. Could it be that nature's creativity in crafting complex structures is far more widespread than we ever imagined? Fast forward 247 million years to a lush Triassic forest, where Mirasaura clung to tree branches with its opposable thumbs and prehensile tail, much like a modern monkey. Its narrow, bird-like face and vibrant, overlapping crest, likely made of keratin, hinted at a life of display and survival. Yet this reptile wasn't a dinosaur, nor was it related to birds. It existed a full 100 million years before the first dinosaur took to the skies. And this is the part most people miss: the crest, though feather-like, was structurally unique. It wasn't a proto-feather but an entirely novel evolutionary invention, suggesting that complex skin structures might have emerged independently in multiple lineages. For decades, scientists assumed feathers and fur were evolutionary monopolies exclusive to birds and mammals. But Mirasaura's discovery, published in Nature, flips that script. As paleontologist Steve Brizat from the University of Edinburgh puts it, "It's been a long time since I've been so blown away by a fossil." The team's analysis of over 80 crests and skeletal remains revealed that these reptiles, part of a group called drepanosaurs, were evolutionary oddities. Think chameleons with barrel-shaped bodies, humped shoulders, and forward-facing eyes. Some even had clawed tails. The closest modern analogy: a pygmy anteater, according to lead researcher Stefan Spijkman of the Stuttgart State Museum of Natural History. But the real twist lies in solving a 50-year-old mystery. In 1970, a Russian paleontologist described Longisquama, a reptile with feather-like structures from Kyrgyzstan. For years, it was a scientific enigma, too strange to fit into the dinosaur bird lineage. Now, thanks to Mirasaura, Longisquama has been identified as a long-lost drepanosaur. The enigma is solved now, says Michael Buckwitz of the Magdeburg Museum of Natural History. This breakthrough not only links two puzzling fossils but also hints at a broader pattern: convergent evolution on a grand scale. These reptiles, unrelated to birds, evolved structures that look and act like feathers. As Brizat notes, they were not bird mimics. It was birds that mimicked them. The implications: genetic blueprints for complex skin structures may have arisen earlier in vertebrate evolution than previously thought. And this opens the door to more discoveries. Could other reptile families have their own versions of feather-like crests? Spijkman suspects so. For now, Mirasaura forces us to rethink what a reptile can be: a creature of color, complexity, and convergence. But here's the question that sparks debate: if birds mimic these reptiles, does that weaken the dinosaur-bird link? Or does it strengthen the idea that evolution is a master of reinvention? We want to hear your thoughts. Do you think this discovery challenges the traditional narrative, or does it simply add a new layer to it?